Welcome back to the deep dive. Today we're embarking on a journey into something that quietly yet profoundly shapes how you see everything around you. We're talking about perspective drawing, and our guide for this deep dive is Sarah Haley's insightful book of the same name. Our mission today isn't just to teach you how to draw, necessarily, but to really open your eyes to the mechanics of your own vision. We're going to strip away some of the complexity and, extract the core insights. Give you a shortcut to understanding how artists translate our three-dimensional world onto a flat surface. And crucially, why grasping these principles can fundamentally alter your perception, making you a more, observant viewer of the world.
Exactly. Perspective is much more than artistic technique. It's a powerful framework for seeing. It mirrors how our brains constantly process depth, even if we don't consciously understand the geometry behind it. We intuitively know a distant road narrows, right? Or a tall building seems to lean as we look up. This deep dive will illuminate those hidden visual rules and show you how they play out, both in art and just in your everyday perception.
Okay, so let's dive into the foundational concept. Linear perspective. At its heart, it's a geometric system, essentially, for creating that powerful illusion of depth on a flat, two-dimensional surface. It's basically mimicking how a single eye perceives space, what's called monocular vision.
Right. And what's truly fascinating is that linear perspective is built on three basic visual principles that your eyes are already using, often without you even realizing it. The first is diminution, which just means things appear smaller the farther away they are.
Yeah.
Think of a distant mountain looking tiny, even though it's massive. Artists like Nicole Eisenman use this powerfully, like in her work Seance.
Mm-hmm.
Second, there's convergence. That's where parallel lines seem to meet in the distance.
Like railway tracks.
Exactly like railway tracks. Christopher Najee Chandler's photograph Foggy Night Road shows this really well. And third, foreshortening. This one's maybe a bit trickier. It's when objects or planes appear to shorten or compress as they recede from your view.
Like if you hold your arm out pointing straight at you, it looks shorter.
Precisely. Padraig Timoney's Riser and Landing is a great example in the book.
It's incredible, isn't it?
Yeah.
Our brains are doing this complex geometry all the time, unconsciously. Artists just learn to map it. So when we translate this into drawing, it all starts with your perspective. The book calls this the station point.
Right, your fixed location as the observer.
Then there's your line of sight, the direction you're looking.
Mm-hmm.
And where that line ends is your center of vision.
Mm-hmm.
Combine your station point and center of vision, and boom, your point of view.
And just shifting your gaze slightly can completely change that view.
Totally.
And that concept, that point of view, is what we translate onto the drawing surface. Your paper becomes the picture plane.
Okay.
Envision like a window, a transparent window between you and what you're looking at. Crucially, this plane is always at a 90-degree angle to your line of sight.
Always 90 degrees. Got it.
And often your center of vision will line up with the horizon line.
That line where the sky meets the ground.
Mm-hmm.
Seems to.
Exactly. Seems to. It's an illusion, but it's a vital reference point in perspective where, diminution, convergence, foreshortening, they all extend infinitely towards it. And everything below that horizon line is the ground plane, the surface things sit on.
Now, you might be thinking, okay, this is conceptual, but how do I actually do it?
Yeah.
We're not running an art class here. But the book really shows how understanding the tools is part of understanding the precision needed.
That's right. Precision is, it's paramount in perspective drawing. Every single line is a calculation. Even a slightly wonky or smudged line can break that illusion of depth. It tricks your eye, makes you see a flat shape again.
Yeah.
So the book highlights needing pencils that hold a sharp point, like harder 2H or 4H for construction lines, and softer ones, like 2B or 4B, to darken things up later. Mechanical pencils are great too, always sharp.
And it has that great tip about pencil pressure.
Oh yeah, the stop, drop, and swap. If you find yourself pressing really hard to get a darker line, just stop. Drop the pencil carefully and swap it for a softer one. It saves your hand, stops you breaking leads or tearing paper, and avoids those ghost lines you can't erase.
It shows how sensitive our eyes are to tiny inconsistencies. And it goes for simple things too, like keeping the paper clean, using white plastic erasers.
Keep the erasers clean too. Sandpaper helps avoid smears.
Right. And even keeping your hands off the paper. The oils can mess things up.
Absolutely. Use tissue, a chamois, cotton swabs, a tortillon, whatever for blending, not your fingers.
Yeah.
And rest your hand on scrap paper if you need to.
Paper-wise, sturdy 60 pounds with medium texture is recommended.
Mm-hmm.
And tracing paper, graph paper, really helpful for complex stuff.
And good tape. Repositionable artist tape is a lifesaver for layering.
And rulers. Can't do perspective without straight lines.
An absolute must. Clear plastic gridded ones are versatile. A T-square for perpendicular lines.
And for angles.
Protractor and compass. Especially a compass with one of those threaded wheels so it doesn't slip mid-circle. Precision, again.
Even the drawing surface itself matters, which is interesting. An adjustable drafting table or easel.
Yeah, angled so the surface is parallel to your face. It helps avoid those sneaky foreshortening distortions, especially when you're working large.
And finally, lighting, often overlooked.
So important. Even sunny days aren't always ideal. The book suggests supplementing daylight with artificial light. At least 2 clamp lamps, one on each side. Full spectrum bulbs mimicking daylight to cut glare and shadows on your drawing. You need to see those lines clearly.
It really drives home how every little detail works together to build that convincing illusion of depth. Okay, so we've got the basics of perception, the picture plane, the tools. But the real engine driving this illusion is the vanishing point.
That's the spot where parallel lines appear to converge to meet in the distance.
Let's unpack the 3 main types of linear perspective based on how many vanishing points you're using. First up, one-point perspective. Think looking straight down a long hallway or a perfectly straight road. One set parallel edges recedes directly away from you.
Right, the walls, the floor lines, the ceiling lines.
They all converge at a single vanishing point. The other edges, like the verticals of a door frame, stay parallel to the picture plane.
And in pure one point, that vanishing point is your center of vision.
Building a simple box is straightforward. Draw the front face, connect corners to the VP, draw the back face, erase hidden lines. Easiest way to show depth.
And a key rule here. Only one vanishing point for the whole drawing, even if you add more boxes or objects.
Why is that so critical?
Consistency. It keeps a single unified viewpoint for everything in the scene. It feels like you're standing in one spot. If you drew an interior, you're inside the box looking at the far wall, which is parallel to your picture plane.
And just by moving that horizon line and VP up or down, you totally change the feel. High horizon gives an aerial looking down view.
See the top of things.
Lower horizon, you're on the ground looking up. Simple shift, big impact.
Absolutely.
Okay, next. 2-point perspective. Now, imagine you're looking at the corner of a building, not straight on.
Right, so it's angled away from you in 2 directions.
Exactly. So now 2 sets of parallel edges recede from you, converging at 2 separate vanishing points, usually placed on the horizon line.
Only one set of edges stays parallel to the picture plane now, typically the vertical lines.
And you build it similarly, right?
Yeah.
Establish the 2 VPs, draw a starting vertical edge, then connect to the VPs.
Precisely. And again, the rule, only 2 vanishing points for the whole drawing. You have to be careful with multiple forms, especially their bases, their footprints on the ground, so they don't look like they're impossibly overlapping or floating weirdly. And the book strongly advises placing these VPs far apart, usually way out in the margins, maybe even taped to the table beside your paper.
Why so far?
To minimize distortion. If the VPs are too close together, things can look stretched or pinched, unnatural, especially near the edges of your drawing. Oh, and the horizon line is still key, but it can become an axis line if you tilt the object off the ground plane. Lets you get those bird's eye or worm's eye effects without needing a third VP yet.
Which brings us to 3-point perspective. This is where things get really dynamic.
Yeah, now everything is angled relative to your picture plane. All 3 sets of parallel edges, length, width, and height converge at 3 different vanishing points.
So none of the edges or planes are parallel to the picture plane anymore.
Correct. Everything recedes. The third VP is either way up high above the horizon for that dramatic worm's eye view, looking up.
Like at a skyscraper from the street.
Exactly. Or it's way down low below the horizon for a bird's eye view looking down. Those 3 VPs form a kind of triangle framing your view.
And the rule?
Still consistency. Only 3 vanishing points total for all forms in that drawing. But here's a neat thing. In 3-point, all lines go to a vanishing point, so you don't have to remember which edges stay straight or parallel. In a way, it can be simpler once you get the hang of it.
Oh, interesting.
But just like 2-point, those VPs are almost always way outside the composition frame to keep things looking realistic and avoid that extreme wide-angle distortion.
Okay, so we've got boxes down in 1, 2, and 3-point, but the world isn't just boxes. How do we draw curves, slopes, more complex shapes?
Great question. The book shows a really elegant technique, Finding the perspective center of any rectangle.
The X trait.
The X trick. Just draw diagonals corner to corner. Where they cross is the perspective center. It sounds simple, but it's incredibly powerful for building complexity accurately.
How so? Give us an example.
Okay, say you want a pitched roof, like an isosceles triangle in perspective. Start with your rectangle in perspective, find its center with the X. Then, from that center, you can draw a vertical line, or one going to the third VP if needed, to perfectly locate the peak of your triangle.
Ah, I see.
Or ellipses, circles in perspective. They are notoriously tricky, often end up looking like footballs or almonds.
Guilty.
We've all been there. But if you draw your bounding rectangle in perspective, find its center, draw perspective crosshairs through it, those give you the key contact points to sketch a smooth, correctly rounded ellipse. No more footballs.
That makes so much sense. And cylinders then just become...
Stacking ellipses. Inscribe ellipses on the top and bottom planes of a rectangular prism in perspective. Connect the sides. Done.
And pyramids, cones.
Same idea. Start with the base, a rectangular ellipse in perspective, find its perspective center, and connect the base edges to an apex point directly above or below that center.
So the big idea is break complex things down.
Exactly. Most complex subjects can be simplified into these basic geometric forms. You can build them up by adding shapes together, additive building. Or start with a big block and carve pieces away, subtractive building. Either way, the key is always start with the largest forms first. Get the overall proportions right before you get lost in the little details.
Okay, proportions. Let's talk about that. Getting the relative size of things right, making it look believable within the scene, proportion and scaling.
Yeah, super important. The book has a great suggestion. Use a human figure.
As a measuring stick.
Pretty much. We're all so intuitively familiar with human scale. Plop a figure into your scene, even roughly, and it instantly helps establish the size of everything else, buildings, furniture, trees.
That's clever. What
Yeah.
about repeating forms like fence posts marching off into the distance? How do you make them get smaller consistently?
For that, you use perspective scaling, often using something called a diagonal vanishing point, or DVP.
DVP.
It's the point where parallel diagonal lines appear to converge. Imagine drawing diagonals across the tops of those fence posts. They'd all meet at a DVP. If the plane is horizontal, like a tiled floor, the DVPs are on the horizon line. If it's a vertical plane, like a row of windows on a wall, the DVPs are on a vertical axis line.
So you can use one DVP to scale flat things, like the width of sidewalk slabs.
Yep. But if you want to accurately scale a 3D form, its height, width, and depth as it recedes, you'll usually need 2 DVPs.
What if the DVP is like miles off the page?
Happens all the time. The workaround is to use a shorter segment of the repeating pattern. Find the diagonal for just 2 or 3 posts close to you that gives you a DVP that's much closer and easier to manage, but it still works for scaling the whole row.
Smart. Okay, earlier we mentioned station point, center of vision,
Hmm.
defining your viewpoint. Let's bring in the cone of vision. What's that about?
The cone of vision represents your natural field of view from your station point. Think about how much you can comfortably see without moving your eyes or head. For most people, it's roughly a 60-degree cone.
60 degrees, like a slice of pie.
Kind of, yeah. And this relates directly back to why the book says put those 2 and 3-point VPs way out in the margins.
Connection.
It's basically a practical way to apply the cone of vision concept. Things inside that roughly 60-degree cone in your drawing tend to look normal, natural. As forms move further out towards the edges of your vision or the edges of a wider drawing, they start to distort. Things beyond about a 90-degree cone look really stretched or squashed.
So artists aim for that sweet spot.
Often, yes. Or they might use a 90-degree cone as a maximum limit if they want a wider view, but still want to keep distortion somewhat under control. The key is usually to make sure the main subject, the important stuff, falls within that comfortable 60-degree zone. And technically, you should always inscribe the frame of your composition within your chosen cone of vision circle for best results.
Another really useful tool mentioned is the perspective grid. Sounds like graph paper, but three-dimensional.
That's a great way to put it. We use 2D grids all the time for scaling and placement. Perspective grids do the exact same thing, but they account for depth and convergence. You just need a diagonal vanishing point, DVP, along with your main VPs to construct them. It lets you map out a grid of repeating squares or rectangles that shrink correctly as they go back into space. Incredibly helpful for complex scenes, like cityscapes or detailed interiors.
And a square grid is particularly useful.
Very, because a square has equal sides, and crucially, its diagonal is always at 45 degrees.
Okay.
So a square drawn in perspective will have its diagonal vanishing points located precisely based on that 45-degree angle relative to your station point. The book shows exactly how to find these 45-degree DVPs for 1, 2, and 3-point setups. And once you have an accurate square grid, you can use it to construct perfect circles in perspective too, using those ellipse techniques we talked about. It's a really fundamental tool.
Makes sense. Then there are plans and elevations. Architects use these all the time.
Absolutely. Plan views are top-down like a floor plan. They show width, depth, and where things are located horizontally. Elevation views are side views, showing relative heights.
How do you turn those flat diagrams into a perspective drawing?
Well, the simplest way is just to draw your plan and elevation on regular grids, then create a perspective grid with the same number of units, and basically transfer the drawing square by square into perspective. But if you want really precise control over the viewpoint,
Which we probably do.
right, you start with the plan view on your paper. Then you place your station point where the viewer is standing relative to the plan, and you draw your picture plane line across the plan. The relationship between your station point, the object on the plan, and the picture plane determines where your vanishing points will be.
Okay, so you plot it out first.
You plot it out. Then you add an elevation view off to the side with a ground line matching the base in the plan, and you draw your horizon line across it at the desired viewer height.
Got it. Plan, elevation, station point, picture plane, horizon.
Then comes the projection part. You draw sight lines from your station point through the key corners of the object on the plan view until they hit the picture plane line. These are your transfer points.
Transfer points, okay.
You drop vertical lines down from these transfer points into your main perspective drawing area below. Then you use your elevation view to get the correct heights, project those across, and connect the dots using your main vanishing points.
Wow, that sounds intricate.
It is methodical, absolutely. What's fascinating is how systematic it is. The book suggests color-coding your lines using a big sheet of paper. It takes patience. But the results are incredibly precise and give you complete control over the viewpoint. Very rewarding when it clicks.
Okay, we've dealt with stuff that fits in grids, more or less. What about things that curve and slope unpredictably? Winding roads, rolling hills, complex roofs. The book calls these dynamic planes.
Yeah, this is where perspective gets really flexible and powerful for capturing the real world, which isn't all straight lines. If a plane changes direction, laterally turns left or right, like a road, you just establish a new vanishing point for that new direction, somewhere along the existing horizon line.
Makes sense. What if it tilts up or down, like a ramp or a sloping roof?
Then you locate a new vanishing point vertically, either above the horizon if it's tilting up away from you, or below the horizon if it's tilting down. For gentle curves, you can approximate them by using several intermediate vanishing points, connecting the short, straight segments. You can even get super precise and calculate the exact vanishing point needed for a specific angle or slope. It gives you enormous control.
Now, this next one sounds really cool. Combining perspectives in one drawing. Like you could have a table in 1 point, a box sitting on it angled in 2 point, and maybe something floating above in 3 point. Is that possible?
Absolutely possible and used all the time. The absolute key to making it look unified and not chaotic is to maintain the same center of vision and usually the same station point for all the different perspective setups within that single drawing.
Ah, okay. So the viewpoint stays consistent even if the objects are oriented differently.
Exactly. You might start with a block in 1 point. Then, using your station point as a pivot, you could use a drafting triangle to find the new vanishing points on the horizon needed for a block, rotated into 2-point perspective, all relative to that same station point.
You can literally map it out.
You can. It allows you to have multiple objects at different angles coexist believably in the same space. You can mix 1, 2, and 3-point. Often you might start with a 3-point setup to establish the main scene and cone of vision, then figure out the VPs for other objects within that space. And for things floating freely, like spaceships or abstract forms, the book suggests using tracing paper overlays. Draw the form, then rotate the tracing paper around the center of vision to place copies at different angles. Very dynamic.
Okay, shifting gears slightly but sticking with realism. Cast shadows. Essential for making things look solid.
Totally essential. They ground objects and describe the light source. To draw them accurately in perspective, you need 2 special vanishing points.
More vanishing points.
Just 2 more for this. The light source vanishing point, LVP, which is the apparent location of the light source itself.
Like the sun or a lamp.
Exactly. And the shadow vanishing point, SVP. This one's usually directly below the LVP on the ground plane or on the horizon if the light is infinitely far away, like the sun. It represents the light source's footprint on the ground.
Okay, LVP and SVP, how do you use them?
You draw lines from the SVP through the bottom corners, the footprint of your object. Then you draw lines from the LVP through the corresponding top corners of the object. Where the SVP line from a bottom corner intersects the LVP line from the top corner above it, that marks the corner of the shadow on the ground.
Connect the dots, and you get the shadow shape.
You connect the dots, and you get the exact shape of the cast shadow in perfect perspective. It's really quite elegant. And the position of the LVP and SVP dictates everything: shadow length, direction, shape, highlight, short shadow. Light to the left, shadow to the right, closer light, bigger, softer shadow perhaps. It all follows logically.
And reflections, like in water or a mirror.
Reflections follow rules too. A reflection is basically a mirror image flipped across the axis of the reflecting surface. Two key physics principles apply. One, the angle of incidence equals the angle of reflection. How light hits the mirror is how it bounces off. Two, the apparent distance from the object to the mirror equals the apparent distance from the mirror to the reflection.
So it looks like it's behind the mirror by the same amount.
Exactly. In the simplest case, if the mirror surface is perfectly parallel to one of the planes of your object, like a box standing on a mirrored floor, then the object and its reflection will share the same vanishing points. You just draw the object, then draw its flipped image using those same VPs.
Nice and easy. But what if the mirror is tilted?
Then it gets more complex. The reflection might need different vanishing points. You might use the object's diagonal vanishing points to help construct the reflection, or sometimes the mirror itself and the reflection might need entirely separate sets of VPs calculated based on the angles involved. The book details how to use plan views or precise angle measurements for these tricky setups.
Wow. Okay, perspective can get seriously complex. The book even touches on multi-point perspective for really wide views.
It does. Standard linear perspective starts to distort badly when you try to capture a very wide field of view. Multi-point systems are ways to handle that, like 5-point perspective. This simulates a 180-degree view like a fisheye lens. It uses 5 vanishing points, 1 center, 4 around it, creating a curved spherical feel. Straight lines start to bend near the edges.
Even 360 degrees.
Yep, you can create full 360-degree panoramas. These usually involve overlapping multiple perspective constructions, often using 4, 5, 6, or even more vanishing points arranged horizontally. Vertical lines typically stay vertical, but all horizontal lines curve following a kind of cylindrical grid. Think of those long, skinny panoramic photos.
Amazing what you can map onto a flat surface. So we've built the structure, added shadows, reflections. What about making it look real? Shade and texture.
The final layer, and maybe the most crucial for convincing realism. Line drawing gives you the form, but value, the lightness or darkness and texture make it feel tangible. Value does so much work, describes the form, the light, the material, everything.
And there are different ways to create value.
Lots of techniques. Hatching, parallel lines, cross-hatching, contour hatching, lines following the form, stippling dots, scribbling, smooth toning, blending. And erasers aren't just for fixing mistakes, they're shading tools too. You can lift out highlights, create soft edges, even make marks with the eraser.
So edges shouldn't just be lines.
For realism, ideally not. Edges should be defined by a change in value between 2 adjacent planes or surfaces. The more subtle value shifts you can capture, the more three-dimensional it looks. A wide range of values, from the brightest brights to the darkest darks, is key for lifelike rendering.
How do you plan all that shading? It seems overwhelming.
Value mapping is the way to go. The book suggests creating a simple value scale, first maybe 5 steps, from white highlight to darkest dark accent. Then figure out your light source, your LVP SVP helps here, and then lightly sketch or mentally divide your drawing into areas corresponding to those steps on your value scale. Number them even. It's like a roadmap for your shading.
Like paint by numbers for light.
Exactly. It breaks it down. Remember basic rules. Cast shadows are darker than the surface they're on. Stronger light or darker shadows, harder edges. A good approach is to start by laying down a light middle value over almost everything. Then use your eraser to pull up the highlights, value 1, 2, and use your pencil swapping for softer ones, not pressing harder, to build up the darker shadows, value 4, 5.
Build it up gradually.
Gradually. Details come last. Be careful not to mess up the big value relationships you establish. Add the little textures and refinements at the end.
And one last touch for depth. Atmospheric perspective.
Yes. That beautiful effect where things get hazy and lighter in the distance. It happens because of air particles scattering light. You can simulate it in drawing by reducing the value contrast on distant objects, make the darks lighter, the lights slightly darker, reduce detail, soften edges, maybe use slightly cooler tones if you're working in color. It pushes things back and creates a wonderful sense of deep space.
It really brings everything together.
This deep dive really shows, I think, how perspective isn't just this rigid technical thing. It's a profound visual language. It gives you the tools to describe reality with incredible accuracy or to invent completely fantastical worlds that still feel believable because they follow these underlying visual rules. Everything we see, literally everything, exists within its domain. It offers just infinite possibilities for expression.
Yeah, it's really driven home the breadth and depth available just through understanding perspective. It's not just for architects or hyper-realist painters. It's a fundamental skill that genuinely widens your ability to render anything you can imagine, whether it's on paper or just visualizing it in your head. So here's something to chew on, a final thought for you listening. Next time you're out, just walking around, maybe looking down a long street or gazing up at a tall building, pause for a second. Try to become aware of those subtle visual cues your brain is processing constantly. The way parallel lines seem to lean in towards a point in the distance. The way the side of a building seems shorter than the front because it's angled away. That's perspective happening, unconsciously, all the time. Can you almost feel where those invisible vanishing points might be? Just out of sight, but shaping your entire visual experience. How might consciously recognizing these principles, diminution, convergence, foreshortening, vanishing points, actually change the way you see the world around you, not just how you might draw it? It really is a whole new lens on reality.